On this question, I want to show how we can use the calculator when given a dataset. So a fluorescent lamp manufacturer guarantees that the mean life of a certain type of lamp is at least 10,000 hours. You want to test this guarantee. To do so, you record the lives of a random sample of 32 fluorescent lamps. Your findings in hours are listed below. Assume the population standard deviation is 1,850 hours. At alpha equal to 0.05, do you have enough evidence to reject the manufacturer's claim? So our sample size is greater than or equal to 30. The claim is that mu is greater than or equal to 10,000. So because they use the greater than or equal to sign, we know that the claim is going to be the null hypothesis. So the alternative hypothesis is mu is less than 10,000. So this is going to be a left-tailed test. Alpha is 0.05, mu is 10,000, sigma is 1,850, and again it's a left-tailed test. So now let's go to the calculator. So now I want to enter in my information. So I'm going to press Stat, and then select Edit, and then type in all of the data, and there's a lot, and then quit out, and go back into the Stat menu, over to Tests, and select Z-Test, and then I want to select Data instead of Stats, and then type in the following information. So mu is 10,000, sigma is 1850. My list is L1 because that's where I entered in the information. I want to specify 1 for the frequency, and then this is a left-tail test. So press Calculate, and here is our information. So Z is negative 1.28, and P, if we round it to 4 places, is actually 0.1000. So Z is equal to negative 1.28. Our p-value is 0.1000. So our picture looks like this. 0.1000 is greater than 0.05. So P is greater than alpha, which means we fail to reject the null hypothesis. So our conclusion would be, at the 0.05 level of significance, there is not enough evidence to reject the lab manufacturer's claim that the mean life is at least 10,000 hours.